Let's try another examples of integrating trigonometric function. You are asked to integrate this. You see there is a power of greater than 1 and there is a multiplications of the functions. You know that in the list of the formulas for the standard integrations, you are unable to integrate this directly. From here, you also observe an odd number of power, which give you a possibility of using the integral formulas of sine power times a cosine. With that, you may take out a cos here. Out of the power of 3, the leftover will be the cos square. From the standard trigonometry function here, rearrange it, you get the cos square x equals to 1 minus sine square x. Substitute this to the cos square x, you get this. Expand the 3 term here, you will get this. From here, you observe there is a powers of sine multiply of cosine. Same goes to this. You may use these formulas to help you to solve the integrations, which give you this. Adopt the boundary conditions. Substitute the upper boundary and the lower boundary. Solve them, you get the final answer. Let us try this example. You are asked to integrate this. The cos is in the power of 4, which is difficult for you to integrate directly. With that, your intention is to reduce the power by expanding using the standard trigonometry functions. Rearrange the function here, you get this. The cos power of 4 can be rewritten in this format. The constant 4 will be taken out of the integration functions. Substitute this into the cos square theta. You will get this. The 1 per 4 here is due to the square of 1 per 2 as a result of the square of the function here. The 4 and 1 per 4 will cancel out each other, and you will need to expand these functions due to the square here. After expansion, you get these functions. Observe the function here. You are able to integrate these two functions separately, but you are unable to integrate this due to the square. With that, you have to do a derivation process to reduce the power here. Use the equation here to substitute the cos square theta. That gives you this. Expand the functions, you will get this. Now the cos are all not in the power of greater than 1. You can integrate every single term of it directly and adopt the boundary conditions. Simplify the functions here. Substitute the upper boundary and the lower boundary and solve the equations.